Hello everyone, welcome to Learn with Wasim. This is Muhammad Wasim Khan, an instructor of your project planning and management course. As you know that in the previous lecture of lesson number 6, project schedule management, we have discussed the two basic processes, that is a plain schedule management and defined activities. Today we are going to discuss a single process, and that is how to sequence those activities. We will discuss just one process today because it will take a lot of time, and I want you to understand it easily and in details. So, what is a sequencing activities process? It is the process of identifying and documenting relationships among the project activities. So, sequencing activities actually is a process which is used to identify the relationship and document those relationships among the project activities. In the second process, that is defining activities, we have defined the activities and prepared a list for those activities. Now it's time to identify the relationship among those activities and to find out which activity will be performed first and which activity need to be performed second, and so on. So it defined the logical sequence of work to obtain about the greatest efficiency given all project constraints. Every activity and milestone except the first and last should connect it to at least one predecessor with a finish to start or start to start logical relationship, and at least one successor with a finish to start or finish to finish logical relationship. Sequencing can be performed by using project management software or by using manual or automatic techniques. So we will discuss in the coming slide that what actually the predecessor is and what is the successor. And we will discuss the four different types of relationship, that is finish to start finish to start, and a finish to finish relationships. Sequencing these activities can be performed by using the project management software, or we can do it, manually. So there are some of the inputs, tools, and techniques and outputs in this particular process. The inputs include a schedule management plan, activity list, activity attributes, a milestone list, a project scope statement, enterprise environmental factors, and organizational process assets. As you know that we have discussed almost all of these inputs in the previous lectures for several times, so we are not going to discuss these inputs here. We need to start directly from tools and techniques. So the tools and techniques include different tools that we can use for sequencing activities, and the topmost of them is precedence diagramming method. Precedence diagramming method, or we call it the PDM, is actually a technique which is used for constructing a schedule model in which activities are represented by nodes. So here we actually represent activities by different nodes. For example, activity A and activity B are the two activities. So you can see that we have represented these activities by nodes, and an arrow or line represent the relationship among these different activities. So activity A is a predecessor and activity B is a successor. Why? Because a predecessor activity is an activity that logically comes before a dependent activity in a schedule. So as you know that activity A comes before the dependent activity B, which is a successor. That's why we call activity A a predecessor and we call activity B a successor. So activity A is called predecessor because it comes before a dependent activity, which is activity B. And we call activity B a successor because it is dependent on a predecessor. It is dependent on activity A. Okay, and before starting activity B, we need to complete activity A first. Okay, so activity on node is one method of representing a precedence a diagram, and this method is used by most project management software packages. So here we need to discuss the four different dependencies or logical relationship. The first one is a finish to start relationship. So it is a logical relationship in which a successor activity cannot start until a predecessor activity has finished. Yani activity B is a successor activity, and activity A is a predecessor activity. So activity B cannot start until activity A is finished. Or we can say, in other words, that a successor activity, which is activity B, cannot start until a predecessor activity, which is activity A, has finished. So this is called finish to start relationship. The next one is finish to finish relationship, and it is a logical relationship in which a successor activity cannot finish until a predecessor activity has finished. So you can see the finish to finish relationship here, that activity B, which is a successor activity, it cannot be finished until an activity A, which is a predecessor activity, until it has finished. So before finishing activity B, it is necessary for activity A to be finished. That's why we call it the finish to finish relationship. The next one is start to start relationship. It is a logical relationship in which a successor activity cannot start until predecessor activity has started. So you can see here that activity B, which is a successor activity, it cannot start until activity A, which is a predecessor activity, has started. And the last one is a start to finish relationship. It is a logical relationship in which a successor activity cannot finish until a predecessor activity has started. So you can see here that activity B, which is a successor activity, it cannot finish until activity A, which is a predecessor activity, is started. So that means that before finishing successor activity, the start of activity A, which is a predecessor activity, is necessary in start to finish relationship. So I hope you understood this simple these simple four types of dependencies or logical relationships. Then we have dependency determination technique. So dependency has four attributes, but two can be applicable at the same time in the following ways. So we have mandatory dependencies like mandatory external dependencies and mandatory internal dependencies. We have discretionary external dependencies and we have discretionary internal dependencies. So for you, I would like to mention here that if you want to remember it easily, so you can divide the dependencies into four. That is mandatory dependency and external mandatory dependency and discrete dependency. Then external dependency and internal dependency. So we can have these four different types of dependencies like mandatory and discretionary. So दो हो गई and external and internal. So four हो गए. So there are four different types of dependency um, dependencies. So let's talk about the mandatory dependency. Those mandatory dependencies are those that are legally or contractually required or inherent in the nature of work. So these are actually the dependencies that are, required or inherent in the nature of work. For example, if you want to construct a building, so before, building a structure, you need to, lay the foundations. यानी आप घर का अगर स्ट्रक्चर बनाना चाहते हैं तो उससे पहले आपको जो है फाउंडेशन यानी जिसको हम बुनियाद कहते हैं वो आपको रखना होगा. So this you can see here that dependency is inherent in the nature of work. That is, it is necessary for you to first lay the foundation and then build the structure. Similarly, I will give you another exam. If you want to sit for an exam, you need to attend the classes, you need to attend the quizzes or assignments, etc. And after that, at the end, you will be able to sit for an exam. So these are called mandatory dependencies. The next one is discretionary dependency. Discretionary dependencies are actually established based on the knowledge of best practices. Like here, in discretionary dependencies, we cannot have any dependency that is inherited in the nature of work. Here we have to establish the dependency based on the knowledge of best practices. For example, we have two activities like activity A and activity B. So for example, activity A is the assignment and activity B is the quiz. So now it's upon us to first, take the quizzes from the students and then, take assignment from the students. Or in reverse, it's again upon us that whether we should first, take assignments from the students and then, uh, quizzes after that. So that actually depend on our knowledge of practices, that actually depend on us. Okay, so there is no inheritance in the nature of this particular work. So that's why we call it discretionary dependency, which is established based on the knowledge of best practices within a particular application area. We call it the preferred logic, we can call it the preferential logic, or we can call it the soft logic as well. Then we have the third type of dependency, and we call it external dependency. External dependencies are those dependencies or in which there is a relation between the project activities and non-project activities. For example, activity A is a project activity and activity B is a non-project activity outside the boundary of project. So this relationship is called external dependency. And this relationship is usually not under the control of the project team. But on the other hand, the fourth type of dependency, we call it internal dependency, are those dependencies in which there is a relationship between the activities within a particular project. For example, we have a project P1. So these two activities are actually the activities of project P1. So the relationship between the activities within a particular project, that is called internal dependency, and it is usually under the control of the project team. Then the third and another important tools are lead and legs. So what is a lead or leg? I would like to discuss it with you with an example. For example, we have two activities, that activity A and activity B. Activity A takes, for example, 5 days to be completed, and activity B needs 6 days for its completion. So total time we need for activity A and B is 11 days or 11 days. In 11 days, we can complete activity A and B because activity A takes 5 and activity B takes 6 days. But for example, is if when we complete activity A in 5 days, if it is not possible for us to start activity B on the sixth day because of some delays or the unavailability of resources, etc. Okay, then that is called delay. Like for example, if we complete activity A in 5 days, and on day 6 on day 7 we wait for example the resources, and then on 8th day we start the activity B, then it will take 13 days, because these 2 days are for the delay. Like activity A is completed in 5 days, activity B is completed in 6 days, but in between these two activities there is a delay of 2 days. So 6 plus 5 is 11, and plus 2 days delay, which is 2, so 11 plus 2 is 13. And so this is called leg. इसको हम लेग कहते हैं, क्योंकि 5th डे पे एक्टिविटी ए को जो है वो कंप्लीट किया गया, लेकिन डायरेक्टली 6th डे पे स्टार्ट नहीं किया एक्टिविटी बी को, क्योंकि 2 दिन जो है वो फॉर एग्जांपल रिसोर्सेज को सप्लाई जो है उसमें, या रिसोर्सेज की अवेलेबिलिटी में 2 दिन लगने थे। तो छठे और 7वें दिन को हमने वेट किया, तो 2 दिन ये हो गई, 5 + 2 7, और फिर 8वें दिन को हमने एक्टिविटी बी स्टार्ट किया और उस पर 6 दिन लगे, तो फिर ये 13 बन जाएगा बजाय 11 के। तो दिस इज कॉल्ड लेग, इसको लेग कहते हैं। Now, if we talk about another example, that is activity A and activity B. Again, if activity A takes 5 days for completion, and completion of activity B we need 6 days, then obviously it will be 11 days. But for example, if we, on the 3rd day of activity A, for example, we start the activity B simultaneously. यानी 2 दिन काम किया, तीसरे दिन हमने एक्टिविटी ए पे जब काम हो रहा था उसके साथ साथ हमने एक्टिविटी बी पे भी काम उसके साथ साथ शुरू किया। ठीक है, तो तीसरे दिन पे हमने शुरू किया, तो इट मींस कि 2 दिन पहले ही एक्टिविटी बी जो है वो छठे दिन को स्टार्ट होनी थी, लेकिन हमने तीसरे दिन पे स्टार्ट की, सो इट विल बी -2, क्योंकि होना तो ये चाहिए था कि 5th डे पे ए कंप्लीट हो और उसके बाद 6th डे पे एक्टिविटी बी जो है वो स्टार्ट किया जाए, लेकिन हमने तीसरे दिन ही एक्टिविटी बी को साथ साथ जो है वो शुरू किया। ठीक है, सो दिस इज -2, क्योंकि 5th को कंप्लीट होना था और हमने 3rd को कंप्लीट 5th को कंप्लीट होना थी एक्टिविटी ए, और फिर 6th को स्टार्ट होनी थी, तो हमने 3rd डे ही पे जो है एक्टिविटी बी स्टार्ट की, सो वो -2 हो जाएगा। सो 11 डेज के बजाय 9 दिन जो है वो लगेंगे। ठीक है, सो दिस इज कॉल्ड लीड। आई होप कि आपको समझ आ गई होगी। So let me revise the definitions for lead and lag. A lead is the amount of time whereby a successor activity can be advanced with respect to the predecessor activity. So this is called lead. Lead is often represented as negative value for lag in scheduling software. A lag is the amount of time whereby a successor activity will be delayed with respect to a predecessor activity. So this example, these two are the examples for you. You have to go through these examples. This is your a small, homework, and you have to, after watching this particular video, you will have to go through this example and interpret this example. I'll ask you about the interpretation of these examples in the coming lecture. Okay. Okay, so let's talk about the outputs of the sequencing activities. Output, the first output is that a project schedule network diagram. So a project schedule network diagram is actually a graphical representation of the logical relationship, and it is also referred to as dependencies among the project schedule activities. For example, we have activity A, activity B, activity C. So when activity A is completed, after completion of activity A, we can start activity B and activity C. And after completion of activity B, we can start activity C and activity D. And after completion of activity C, we can start activity G. And after completion of activity D, we can start activity F, and so on. So this is actually one of the the rough example of the graphical representation of different logical relationship, or the graphical representation of the relationship among different activities. So a project schedule network diagram is produced manually or by using different management softwares like project management, like Microsoft Project or Primavera P2, etc. So these are different software that can be used for drawing the project schedule network diagram. So it can include all project details or have one or more summary activities as well. Any unusual activity sequence within the network should be fully described within the narrative. So this is the project schedule network diagram. We will discuss it inshallah in the coming slides. Then we have the project document updates. Project documents that may be updated include but are not limited to: you will have to update the activity list, you will have to update the activity attributes, the milestone list, and the risk register that we have discussed in the previous um, lecture. So let's talk about the sequencing activities. As you know that we have discussed here the project schedule network diagram. So we are just going to discuss the project schedule network diagram on this particular slide. So please, be attentive, to this particular example. These A, B, C, D, E, F, G, H, I, J, K, L, these are different activities, okay? And these are the nodes. The rectangles represent the nodes. So we have at the start, we will have the beginning node, the start of the project, and we will have the ending node or the end of the project. Okay. As A, H, and K are the independent, they are not dependent on any other activity. Therefore, we will start it first. Okay. So we have started activity A, activity H, and activity K. Okay. Now, when activity A complete, the activity B will start. Okay. Similarly, an activity C will start after the completion of after starting activity B as well. Now activity C and activity F will start. You can see the arrows. Activity C and F will start after the completion of activity H. Okay. Similarly, activity I will start after starting activity H. You can see the start to start relationship here. And activity I and KL will start when the activity when activity K completes. It means that we can start activity I and L when activity K completes. Now let's talk about activity B and E. We can start activity uh, D, okay, after finishing activity C. We can start activity G after finishing activity F. We can start activity J after finishing activity I and activity L. Okay. Now we can start activity E after the completion of not only D but also activity B. You can see the arrow here. So after completion of activity B and D, we can start activity E. Okay. And when activity E, activity G, and activity J, sorry, when activity E, G, and J finishes, it will be the end of our project. So that was actually the basic schedule network diagram, and we will explain and we will discuss this diagram in details, but it is very necessary for you to understand this one, because if you want to understand the coming chapters or the coming lectures, okay, so you must need to understand this particular example. And I hope you understood this you will understand this particular example here. So I'll try to discuss another example with you so that you can easily understand it. This is called the activity list. Here you can say we have the activities list: activity A, B, C, D, E, F, G, H, I, J, K. These are the activity names, and these are the activity codes, and these are the predecessor activities. So it depends. If we have any one of the predecessor or successor activity list, we can draw a network diagram. Okay. So here activity A is independent, there is no predecessor for activity A. Similarly, activity B is independent, we don't have any predecessor for activity B. Activity C has a predecessor, it depends on activity A. Activity D has also a predecessor, which is A. That means that activity D depends on A. Activity E has also a predecessor, which is activity B. That means activity E depends on B. Similar, activity F depends on C and D. Activity G depends on E. Activity H depends on E. Activity I depends on C. Activity J depends on F and K and F and G, and activity K depends on activity H. Okay, so let's okay, so these are actually the basic relationship. Activity C, A, activity, A will start, A will, C will start after completion of activity A, D will start after completion of activity A, E will start after completion of activity B, F will start after the completion of activity C and D. G will start after the completion of activity E, H will start after the completion of activity E, and so on. So this is actually the relationship. This is the network diagram for all of these activities. This is the starting node, and and we will have the finishing node or ending node. Now, activity A and activity B. Here you can see that both of them don't have any dependency. So we will have activity A and activity B. Okay. Now, activity C and activity D depend on A. So activity C and activity D, they both depend on A because they have activity C and D have a predecessor A, which you can see here on in the list. If we look into the list, then we can see that activity E has a predecessor B. Activity E has a predecessor B, and activity F has a predecessor C and D. It means activity F depends on C and D. So activity F, this is activity F, it depends on activity C and activity D. Similarly, activity G depend on E and activity H depend on E. So you can see here activity G and activity H depend on E because activity G and H has a predecessor activity E. And similarly, activity activity I has a predecessor C. So activity I has a predecessor C. Okay, I depend on C. Acha, activity J has a predecessor F and G. That means activity J depend on F and G. And if you look into the K activity, which depend on H, so activity K depend on H. And when at the end when I and J, and so here we can say that if after the completion of activity A, we can start activity C and D. After the completion of activity B, we can start E. After the completion of C and D, we can start activity F. After completion of E, we can start activity G and H. After the completion of J, we can start, after the completion of, F and G, we can start activity J. And similarly, after completion of C, we can start activity I. And after completion of H, we can start activity K. And when all of these three completes, our project will finish. or project will come to an end. So this is actually an activity sequencing. In the previous lecture, we have defined the activities, and we had the activity list, which you can see here on the left side of the screen. Now we have actually identified the basic, I would say, sequencing or the network diagram for all of these activities. And this diagram actually tells us that which activity will be performed first, which will be the activity will be performed second, and which activity is the predecessor, which activity is the successor, and what is actually the relationship among these activities. So that's the end of the third process, that was the sequencing activities. So till now we have discussed what actually the project schedule management and what is the schedule model. Then we have discussed the planned schedule management process and what are the inputs, tools, and techniques and outputs. So we have discussed all of these things in the previous lecture, if you remember. Then we have, in the previous lecture, we have discussed what is defining activities process and their inputs, tools, and techniques and outputs. And today we have discussed the third process, that is what is sequencing activities process and what are its inputs, tools, and techniques and outputs. So that's the end of today's lecture. I hope you will understand this lecture. But if you have any question, you can please email me or call me, or WhatsApp me, and I will try to give you um, an answer of your question as soon as possible. Till then, thank you and bye bye.